In this video, we're going to look at two important examples of principal ideals. The first thing that I want to do is I want to remember the definition. The definition of a principal ideal is that if we have R is a commutative ring, and A is any element inside R, the principal ideal generated by A is the subset R times A, where R runs over all of the elements of the ring. In the last video, we saw that if the commutative ring does not have a multiplicative identity, we don't know whether or not A actually is an element of this set. If the commutative ring does have a multiplicative identity, we've seen that A will belong to this set. In this video, we're actually going to be looking at principal ideals of a couple of special elements. So our first example. I'm just going to let R be any commutative ring. And all rings have a zero, so I want to look at the principal ideal generated by the zero inside R. Well, from the definition, that's going to be R times 0, where R is ranging over all of the elements of R. But we know that R times 0 is equal to 0, and that is true for all elements inside the ring. And hence this set winds up just containing the 0 element. And so the principal ideal generated by 0 is always going to be the 0 ideal. And that's worth knowing. So let me get this written in better English. In any commutative ring, the principal ideal generated by the 0 element is just the 0 ideal. Our second example is going to concern rings with multiplicative identities. So our second example, we're going to let R be a commutative ring with a multiplicative identity element. And in this particular example, I want to look at the principal ideal generated by the multiplicative identity. In other words, the principal ideal generated by 1. Well, again, if we just look at the definition, this is going to be R times 1 as R ranges over all of the elements inside the ring. But if we think about it, I know that R is actually equal to R times 1, and so this set is nothing more than all of the R's inside the ring itself. In other words, the principal ideal generated by the multiplicative identity is always going to be the ring itself, and that's also worth writing down as a fact. So, in any commutative ring with identity, the principal ideal generated by the multiplicative identity is going to be the whole ring. And that ends this video.